Welcome to Chapter 4 homework. So, that's a fun little pop-up that pops up. But anyway, so starting off first with question 1 as we dive into more formulas and reading graphs. Basically, this is all you're doing is reading a graph right here and wants to know the maximum and minimum numbers of cell phones sold in a day. So again, I look at the smallest, which happens to be 4, and the largest at 19. It also wants to find the median. Okay, remember median is just the middle, and since we have 26, this is an even number. So 26 basically divided by 2 is 13. So we find the 13 numbers from each side, and we find the 2 numbers we add and divide by 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Most likely, if I count backwards, the 13th will be the number above. So since they fall in the same row, it's only going to be this number. We don't have any changes to it. So that should be 12. Because if I go 9, 10, 11, 12, 13, 14. Again, check your work. Make sure everything is correct. Awesome. Alright, so next one, we find our quartiles. And since this is a small data set, not going to really use Excel right here. I would if it's a little bit bigger, but it just doesn't need it. So finding the median, first thing that we have to do is make sure it is sorted. If it wasn't sorted, then we would use Excel, make it a little bit easier. But it does look like it's from smallest to largest, so we don't have to worry. Let's see if we have an odd or even number data set. Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have odd. So that means one of these is our number. Don't have to do averages or anything. We just have to find the middle. And since the middle is for 11 would be 6. Basically the easiest way to find the middle, take how many numbers you have, plus 1, divide by 2. It has to be the 6th number. So 1, 2, 3, 4, 5, 6. It's 53. And if I check, I should have 5 numbers on the other side as well. Alright, next we're going to find the quartile. So we need our calculator. Make sure you always clean out your calculator, just in case there's extra numbers. And to find our first quartile, we take how many values are in our set, which happens to be 11, add 1, which is 12. And then for the first quartile, you multiply it by 0.25, which means our first quartile sits at the 3rd position. That would be 49. Do not put 3. 3 is not the answer. That only gives the position of that quartile. Same thing. Taking that 12 multiplied by 0.75 shows us our 3rd quartile is in the 9th position. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Happens to be 55. All right, there we go. Check. And our numbers are indeed correct. Question 3 has different parts. But the first one is what we've already done, which is the 1st and 3rd quartile. Again, if the data set's in order, we don't really have to go after the Excel. But because it's a little bit bigger, I'm going to go ahead and put Excel out here. And we can see that it is in numeric order. Just now I'm going to use it because it's such a large data set. We can use it as our counting tool. So I'm going to, gotta remember to hit enable edit. Delete that. So I start with 1. And this shows I have 30 numbers. Okay. We're not looking for the median. So first and third quartiles. Well, take our calculator. We know we have to take 30 plus 1 and multiply by 0.25 for our first. Notice we have a decimal. So that means that this number, the first quartile, does not sit in the 7th position. It's in between the 7th and 8th position. So let's find those two positions. Okay, so it sits between these two, 7th and 8th. So we got 34 and 32. So in order to find this number, we need to take wherever this decimal is. We're going to use that a little bit later, but you take 34 minus 32, so your highest number minus your lowest, to find the interval, which happens to be 2. And then you multiply it by that decimal, so 0.75, which shows that it's going to be 1.5. And then add that to your lowest, 32. Apparently mine is 33.5. Let's make sure. Yep. So we found the first quartile. Now it's time to move to the second quartile. All right, not second, third. Third quartile. So again, calculator. We already know it's 31 times 0.75. This is going to be in between the 23rd and 24th because I have a decimal again. So using our Excel, 23, 24. So again, same thing. I'm going to take on the calculator, take the highest, which was 51, minus the lowest, 49. Again, I'm with 2. And multiply it by 0.25. I believe that was it, which ends up being 0.5. So 49 plus 0.5 makes it 49.5. And we are correct. So there's our first and third quartiles. Quartiles are a little bit easy. Next, we have deciles. So deciles work a little bit different. We need to divide the data set into 10 equal parts. Alright. So when it's looking for the second decile, to do this, calculator. Again, we still will have 31, but we need to figure out what is the position or the percentage for the second decile. So in order to figure that, we take 20, divide by 100. Again, putting out into tens. And then now multiply it by 31. So this position is in 6.2. So using our data set, we find the 6th and 7th position. Which again, we have to do everything in 32 minus 29. This one's 3 for the interval. Multiply it by 0.2. Will be 0.6, so 29 plus 0.6. Let's say that our second decile will be 29.6. Now we got to find the 8th decile. Which all we have to do, again, calculator. This time, take 80, divide by 100. It's 0.8 times 31. It's going to be the 24th position, between 24th and 25th. Okay. So that's 51, 53 for me. It's going to probably be a little bit different numbers. That's okay. Same principle. So 53 minus 51 is 2. Multiply that by 0.8, 1.6, plus our lowest, which was 51, 52.6. Check to make sure we got both our deciles. We do. Our second and 8th. Now lastly, we figure out the 67th percentile. So, this is saying that when we go into 67th and all these, it's basically we broke it down to 100 equal parts. So, calculator, take 67, divide by 100, 0.67. But basically, take that and then again multiply by 31. How many numbers in the data set plus 1. Comes out that the position is 20.77. So, we got 44 and 47. So 47 minus 44, 3 again, multiplied by 0.77, 2.31, plus our lowest, which was 44. We're looking at 46.31. There we go. That's question 3. Again, you may have something completely different on the numbers, but the principle is still the same. Remember, these algorithmics give each other different numbers. Question 4 is a box plot. So, with box plots, again, we'll go and just look and see what it does. And when we find the median is always this big old dark line in the box plot. Box plot. So that ends up being 450. Estimate the first and third quartiles. Again, these are going to be basically the ends of the box. So the first one is going to be 300. And the third one is going to be 750. Again, keep checking. Alright. Next, interquartile range. Alright. So basically the range is going to be 750 minus 300. Basically the difference of these two. So 750 minus 300 will be 450. That is our interquartile range. Again, that's basically the shaded area. Alright. Beyond what point is a value considered an outlier? Okay. So, should be less than basically less than 300 minus 450. So And since 300 minus 450 is going to be a negative, we're going to have 0. Anything more than 750 plus 450, basically 1.5 times 450, that'd be 1425. So yeah, 450 times 1.5. So it's 675. That's what we're doing, 1.5. It's always outlier more than 1.5 times than our range. Okay, so 300 minus 675 is a negative. We only do 0. More 750 plus the 675 equals that 1425. Okay, so all you do is take your interquartile range and multiply it by 1.5. And then you add and subtract to our quartiles. Okay, so what does that mean? Identify any outliers, estimating their value. If there's none, there's none. We see an asterisk right here at 1500, which is an outlier. Okay. And I'm going to basically leave the last one to you, because again, that's just a multiple choice. So, yeah, remember, what does it mean to be positive or negative skewed? So, which way is it going? Which one has the longer area? Make it more positive or make it more negative? That's going to be up to you. Okay? Next. One of our fun ones. So, I know we're going to love this. Even though we got a small data set, I am definitely going to use Excel. Pop up. Enable editing. Alright. So, first thing that we have to do is, again, find the average. Basically the mean. Okay. So, auto sum. Formulas. Sum is 154. 154 divided by 1, 2, 3, 4, 5. Equals to 30.8. This is our mean. Nice. Okay. So, here's our mean. Mean is 30.8. Median. Again, we're dealing with only 5 numbers. It is not sorted. So we should, let's do that real quick. Sort. Okay. So now they're sorted. Smallest to largest. And that makes 31 right there in the middle. That's our median. Okay. Now standard deviation. The fun one. So back to Excel. Alright, first thing that we have to do is take basically x minus x bar, which is the average. So this is going to equal this minus 30.8. There we go. Always make sure you add them up to make sure that comes out to 0. Most of the time it's going to come out to 0 when we figure out standard deviation using this method. So next, it's x minus x bar squared. Okay, so it's equal that times itself all the way down. Formulas, auto sum, which comes out to 62.8. Then all we do, equal, formulas, math and trig, find our square root. Square root of that number. So, our number, standard deviation, is of course 7.92, so forth and so on. Yep, 7.92. We're going to check to make sure we have all three. May have missed a number here. Okay, so I forgot a step. Sometimes that does happen, especially going through all these items. So we forgot to actually find the mean of this. That's where we get our standard deviation. Now, since this is a sample size, we need to take that's equals 62.8 and divide by 4, not 5. Remember, sample sizes we take n minus 1. So that becomes 15.7. And again, we're going to square root that number. There it is. Okay, so it's supposed to be 3.96. Slight off, but that's important. Gotta find the mean. The mean. Okay, so we have standard deviation. Okay, now it's time to figure out, determine the coefficient of skewness using the Pearson method, and then using the software method. Two fun ones. So, Pearson's coefficient of skewness is 3 times the difference between the mean and the median, divided by the sample standard deviation. Okay. All right. So, we're going to take the difference between these, calculate 0.8 minus 31, multiply it by 3, okay, and then divide by 3.96. Which equals to 0.015. This looks like negative 0.02. But it seems like there is a mistake. Yeah. So they have it as negative 0.15. Yeah, I think they... So, it looks like Connect actually messed up here. So, let's try that again in our calculator. Okay. So, we take 30.8, which is our mean, minus our median in 31, negative 0.2, times 3, times 3 point, or not times, divided by, clear, negative 0.0. Divided by 3.96. Okay, I might have added an extra 0 somehow. Where's my history? Okay, I want to see what happened. Okay, not there. Huh. Oh, okay. Somehow I multiplied by 0.3. Yeah, sometimes you have to check your math. If it doesn't look right, there's something wrong. Somehow, I don't know why I typed in 0.3. That's funny. I will have to say, that is funny. Now, determine the coefficient of skewness using the software method. Alright. So this one, we're going to have to go into Excel. Just because we're going to have to do a little bit more fun stuff. First thing that we have to do is that we're going to have to take each one of these. And again, we're going to have to minus and divide. All right. So, try to remember how to do this. So again, we have x minus x bar. So we're going to have this equal to these numbers divided by our standard deviation. Okay. So again, we gotta have x minus x bar divided by our sample standard deviation. Now, while I would like to do that, we want to go ahead and make it the simple form. So I can just drag down. Boom. There's our numbers. Again, this is not going to add out completely to 0 because we're rounding. But now we take this and we're going to cube it. Okay. So, equals this times itself again. There's our numbers. We find the sum, the formula, auto sum. And then next, with that being said, once we found the sum of these numbers, we're going to take n, how many numbers we have. So 5 divided by n minus 1, which is 4, times n minus 2, which is 3. Make sure you put your equal sign if you're going to put it in here. So 4.41667. We'll multiply these two. So equal this times this. So we come out to 0.12561. So let's see, what does it tell us to round to? Round to your answer to the nearest 3 decimal places. So that's going to be 0.126 for us. Yep, round up 1. Let's check. Okay, good. Now, if this does have an X and you have done everything right, maybe just keep it at the same. Sometimes there is rounding errors because we are doing a lot of rounding, and connect has to be certain percentage-wise. So that could be an issue. Alright, so that finished 5. We're halfway through. Whew. And it's not going to get easier. Okay, so next we have the same thing going on. So this one has 15 sales representatives. You got to find the mean, median, standard deviation, and both of these. So again, exactly what we did for question 5. I'm not going to go over it again because it's the same basically format that we just went over. So again, best thing to do is make sure you put them here. Put them in sorting position or in order so you can find your median. And then again, at least make x bar squared so you can find your sample standard deviation. Watch out for that n minus 1. Then make sure for the software version, x bar divided by s, your sample, and cube it. Should actually say cubed. Okay. And if you have questions or need a little help, again, you can always email or text me to the number that's on the syllabus. All right. Question 7. Question 7 wants us to find the correlation coefficient. Okay, so we have x, we have x's and y's. Editing. Alright, so since we have 2 different variables going on, we know rooms and labor. We have 2 items. So our correlation coefficient is the sum of x minus, basically it's medium times, again, the sum of y minus y bar, basically their median. Okay, and then we're going to have to find the standard deviation or sample standard deviation of each one. So basically it's 2 charts, fun stuff. So I'm going to take this, we're going to cut it, and we're going to place it okay, they just want to have some fun. Alright. There we go. Probably add a couple more so I can do the summary for x. Alright. The only reason why I'm doing that is so I can make my fun chart as we did before. Again, I typically do these all by hand. Makes life a little bit easier for me. sum or wait a minute, let's see, formulas, statistics, I wonder, as I often do, I wonder. Nah, there's confidence, forecast, gamma, a lot more statistics than we're ever going to ever get into. Let's see. Ooh, look what we found. We found quartile. Let's go. Okay. Array 1. There we go. Whoops. Probably need to put that somewhere over here. Let's see what we got. So formulas. We're going to insert. There it is right there. Oh. Okay. We'll put our first array, which is X. Put in our second. Oh. First. And our Y. Okay. See. Okay. So, Excel will just calculate it for us at 0.82712. Let's see if that's correct. Work smarter, not harder. So that was point, said 2 decimal places, so 0.8283. 0.83. Let's check. Boom! Yay! So instead of making this a very long video of going through it by hand, we just found the formula. Woo! Using Excel. Yay! Okay. When you're a professor and you find the shortcut, sometimes that makes you happy. With this, that made me very happy. But if you do want the long version, just email me. I'll do the long version for y'all. Alright. But if we can use the software, let's use the software. Alright, question 8. Alright, question 8, I'm not going to typically go over, because again, this looks like a simple questions of asking you if ordinary or number, shares and ratio or categorical, and then what is this table called, and what group seems to strongly oppose the merger. So that's basically reading that, and since it's all dropped down to multiple choice, not typically going to go over that. Alright, so question 9 though. This looks big. Alright. So question 9 has a lot of stuff that we've already done, even though it looks big. We have our coefficient of skewness using the software method. So be careful of that. That was the one where we had the cubed. We have all of these information, mean, median, standard deviation, which we have done. So I ask you, what's the skewness? Okay. And also finding the first and third quartiles. I like how it says, do not use the method described by Excel. I guess that comes out to a different answer. So, by hand like we've been doing. Again, not extremely difficult formula on that. And then limits for outliers. Okay. So this one, that's a new item. Seems like we're going to have to make the box. So, again, you're going to make the box, but you really don't have to, because all you do is once you find the first and third quartile, just like when we had the box plot, is that you take the difference of these two, which basically becomes our interquartile, times that by 1.5, and then subtract it from the first one and add it to the third one. That will come out to these. If it happens to be negative, you may need to put 0. And it's going to ask for any outliers. Basically, if they fall outside this range. So it's going to ask for. I doubt that. I bet it's going to be 0. Let's see what 10 is. Alright, 10. So, 10, you can draw a box plot and see if it does show any outliers. Again, I could probably do that in Excel. Let's see if we can do it in Excel. So we're looking for, I guess, price. Yeah. Because you get multiple items here. Lots of fun stuff. So draw a box plot. Yeah, variable for price. So let's see. Insert. That's our scatter. There's our pie. Box. Okay. Oh, probably needed to highlight. So, price. Insert. Box. Okay. So basically that's on its heel. Let's see if we can put those two formulas. Yeah, since there is none, they're just going to show that. So, that's a fun one. Rather have it opposite way. So let's see. Delete. Alright, so that actually gives us our numbers. Outliers and whatnot. Looks like we got a few outliers for what it is showing. Yeah, it only puts it like that. I'd rather have it flip. But yeah, so Excel can show, and it does show us some outliers. So even though it's on the going top bottom, it's still the same as we go. And then you can find the median and price. Again, using Excel, first and third quartiles. And again, I think Excel is showing us right away. This is our median right here, which is 3,733. And here's our first and third quartiles, 1,477.5 and 6,141. Alright, and then once you draw a box plot for the variable size and comment on the results. So doing the same thing, and then doing a scatter plot. So pretty much on this one, you are really just showing, can you make graphs? At the same time, do you understand what the graph is? So it's like, what's the most common cut? What's the most common shape? What's the most combination of cut and grade and shape? Okay, so that's using actually a dot graph. If you want to use one of those, or a contingency table. Probably use a contingency table. It's easier to total. Again, that's going to be completely up to y'all. So, number 9 is probably my good test to see how well you understand this chapter. Okay? Again, if you have questions, you can always ask. Just let me know. Okay?